In this illustration, we'll analyze a case of a slit in a cylindrical vessel. We are given that a wide cylindrical vessel of height h is filled with a liquid of density ρ. On the vessel wall, there is a narrow slit running down to the bottom of vessel, and the slit length is L and its width is equals to B. And it is saying when liquid is filled in a vessel, slit is closed. If suddenly the slit is open, we are required to find the force of reaction of water flowing out just after opening the slit. Here, to understand the situation, let's first draw the figure. On ground, we are given that a wide cylindrical vessel is kept on this ground. Say if this is a wide cylindrical vessel is kept over here, and in this vessel we have made a slit on its side wall. Say this is a rectangular slit which is made, and we are given that the slit length is L and the width of slit is equals to B. That means this width is given as B. So this is a rectangular slit, narrow slit is made in the side wall, and liquid is completely filled in it, which is water in this case. And in this situation, the vessel height is also given to us as h, and the water density here we can consider as ρ, which is also given to us. Now, when suddenly the slit is open, water will start coming out from the slit throughout this length. So, due to the ejection of water, the vessel will experience a backward reaction force, which we can calculate by considering an element from the top at a depth x below the open end of the vessel, and we consider an element of a slit of width dx. So here we can say if we consider an elemental opening in a slit of area, this will be B dx because the width is B and length we are considering as dx. Then we can say a flux velocity of water from this opening is, there's a flux velocity we can say as it is considered at a depth x below the open end. So this will be root 2 gx, and we can write the force of reaction due to water ejection from this element is, this we can write as dF, and the value we know, the reaction force is given as rho a v square. We already studied in concepts. So here we can write it rho. Area is given as B dx for this elemental opening, and the velocity is root 2 gx whole square. So the value of total reaction force we can give as integration of df, which is here we can take the constants out, which is 2g rho b, and this is the integration of x dx, and limits of integration here we substitute from this point to this point, that will be from h minus L to h. And if we integrate this, the value of force, I continue here, this will be given as 2g rho b multiplied by its integration as h square x square by 2, and we apply limits from h minus L to L. Now you can simplify after substitution of limits, and this will give us the value. This 2 gets cancelled out, and the final result we'll be getting is rho g L B multiplied by 2h minus L. That will be the result of this problem.